how do we solve circuits with any kind of periodic input? So just as an example, we're talking about feeding a circuit a square wave and what do we get out? Let's see, Chow. If we feed a circuit a square wave, are we guaranteed to get a square wave out of a different magnitude and a different phase?
Yes.
I had a 50-50. So it's only true for a sine wave. So for a sine wave into or cosine wave with a, it doesn't matter if there's as long as it's fundamentally a sine wave, it can have a phase offset. But if you put in a sine or a cosine wave into a circuit, you're guaranteed to get out a cosine or a sine wave, just with a different magnitude and a different phase. And that is the only input that we'll be talking about as an undergraduate. And it's the only common input. There are very specialized other ones, but it's the only common input which guarantees an output of the same form, just with a couple of parameters shifted. In this case, phase and magnitude. And that's the basis for all of our phasor analysis. But no other waveform has that property. If you put in a square wave like this, you might get out something that looks like this kind of ocean wave thing, if it's a low pass filter. Or if it's a high pass filter, you might get something that looks like this, that looks totally different than your square wave. So it's a complicated problem to solve. And the way you're going to solve it is you're going to first find those Fourier series coefficients in rectangular synthesis and rectangular analysis of your input waveform. And then once you find that, you're going to change those into this form, into your polar form. Then you'll find your H of omega of the circuit. So far this dealt with your signal, and this deals with a system. Here's your input signal, here's your system, and then you're going to go back to you're going to go back to the methods that you just used in the lab, which is very similar to the methods you used in signals and in EE230 in circuits. For every input, A sub n at an angle of phi sub n, you will find the output. So this isn't an infinite sum of them. This is one particular input cosine wave that has a magnitude A sub n and a phase offset of phi sub n and a frequency of n times omega naught. And you're going to find the output. And I'm going to label the output using the same kind of notation, but I'm going to put in a prime symbol in there just to show that's our output. And you find it pretty easily. It's just equal to our input times our H at n omega naught. In other words, we're just going to evaluate n at the corresponding frequency. And see if you can realize that all that we're saying is our output y is equal to our input x times our h. It's no different than what we did in Laplace systems. So this is going to be a complex number. This will be a complex number. Multiply them together, we'll get a complex phasor output. And now that you've done that for every single frequency, you can now synthesize your output. It'll be equal to your fundamental plus the infinite sum we covered in the other page, which is our magnitudes and phase offsets. So questions about the approach? This is our step-by-step approach for solving circuits with a periodic input.